Modeling with absolute value inequalities. Here are two examples of real-life situations that are modeling and we can solve or find a solution and graph it with absolute value inequalities. The first example is a modern hot water heater is designed with a thermostat to heat water to safe levels. The standard thermostat maintains the water temperature to within 3 degrees of 118 degrees Fahrenheit. So we need to sketch a graph and write an absolute value inequality that gives the range of the water temperature T so that it's consistent with the standard thermostat. So if you're within 3 degrees of 118 degrees Fahrenheit, you have the meaning that you're 3 degrees above 118, which would be 121 degrees, and you're 3 degrees less than 118, so 118 minus 3, you're 115 degrees Fahrenheit. So you have this range from 115 degrees to 121 degrees. That means we equal those values so we can have closed circles at 115 and 121, and our temperature T is everything within those values. So we have 115 is less than or equal to T is less than or equal to 121. If this is an AND inequality with a center at 118 and a distance of 3, if it's less than, if it's AND, we can rewrite it as T minus 118. The absolute value is less than or equal to 3. Here's the second example. That each year at the state fair, there is a competition to grow the largest pumpkin. In recent years, the champion pumpkins have weighed within 340 pounds of 1,180 pounds. So sketch a graph and write an absolute value inequality that gives the range of the champion pumpkin weights W. So W is within 340 pounds of 1,180. So you can have 340 pounds more, which is going to equal 1,520 pounds, or you can have 340 pounds less, which is going to equal 840 pounds. So you have this range from 840 to 1520. So if we graph it, we're marking 840 and 1,520 on the number line with closed circles, and we have everything in between. So you have this idea that you're at a center W, and you're moving to the left or to the right 340 pounds. So our center, that weight we're comparing, we can write it as an AND inequality of 840 is less than or equal to W, which is less than or equal to 1,520. And if we want it as the absolute value inequality, we have our center being 1,180. Now we know that's the weight we're comparing to in the middle. And we're going a distance of D equals 340, so that will give us the absolute value of W minus 1,180 is less than or equal to 340. So with these real life situations, these real life problems and modeling, you really want to look at what's your center, what's your distance, and what are your two endpoints so you can rewrite it in whatever form they desire.